Hey, all you cool cats and kittens, it's Miss Damaso. We are going to go over our week 7 video 2 notes. This is our final video for new material. So this is 10.6, arc length and sector area. After this, you will have a study guide video next week on Monday, and then you'll take your final quiz next week on Thursday. And then we are finished with the year. So pretty exciting stuff. So let's get ourselves jumping straight into it so we can get going. This will be a little bit longer of a section just because I kind of meshed as much as I could into this last one to get it to be the final video for this week and for this quarter. So just bear with me if it is just a little bit longer than normal. Okay, so we're talking about 10.6. We're still on circles, and today we're going to talk about arc length and sector area. So the first we're going to talk about is just arc length. Arc length is when we take a look at the length of an arc in portion of the whole circumference. So circumference is if you were to go all the way around the circle. Arc length is looking at just one piece of that whole circumference. Now, there's a special formula we use in order to figure this out. Our formula is L for arc length is equal to, we take whatever the degree is of the angle, so x degrees, whatever it is, and we multiply that times the circumference, and then we divide it by 360 degrees, which is the whole circle. Now, x is the degree measure of the arc, c is my circumference. There are two ways that you can figure out circumference. Either you can do 2 times pi times r, the radius, or you can do pi times diameter, depending on what is given to you in the problem. You can use it either way. So let's jump right into some examples. I'm going to zoom in. Find the length of each bolded arc to the nearest hundredth. Okay, so to find the length, I take the arc measure that I want. I look for the angle that matches it. This is a central angle, so this angle right here is 107 degrees times the circumference. Circumference, this time I am given this piece right here is 6 meters. This is a radius. So I'm going to use 2 pi r because I'm given the radius. So times 2 pi r is 6. And then I divide that whole thing by 360. So the first thing I'm going to do with my calculator is I'm just going to multiply the numbers on top that are just in numbers. So I'm going to do 107 times 2 times 6. That gives me 1,284 times pi over 360. So I'm going to take that number. I'm going to use the pi button. So hopefully you have a pi button. I'm going to multiply that times pi, and then I'm going to divide that by 360. My answer for the arc length is approximately 11 point, and I said hundredth, so 21. And it's in meters, and I'm finished. Not too hard. Let's try the next one. Arc length equals, I take my degree measure that's given to me, 38 degrees, times the circumference. I am given the radius, so I'm going to use 2 pi r. So 2 times pi times my radius is 15, all over 360. Again, I'm going to do the same thing. I'm going to multiply just my numbers together first. So 38 times 2 times 15 gives me 1,140 pi all over 60. Now I'm going to take 1,140. I'm going to multiply that times pi, and then I'm going to divide that by 360. I get that my arc length is 9 point, and I'm rounding to the nearest hundredth, so I'm going to round it to 9.5. And I'm looking at inches. And I'm done. Not too hard, right? Okay. Number 3. Now, this time you will notice I give you this angle right here is 142 degrees, which matches with this piece out over here, but I want you to figure out this arc length over here that's bolded. So now, kind of going back to some things we learned, I know the whole circle's 360. I know this piece is 142. To find what's left over for this angle right over here on the inside, I'm going to do 360 minus 142. And that's going to tell me what's left over on the inside there, which is 218 degrees. Okay, now I have the right information and I can plug it into the equation. So my angle is 218 degrees times 2 pi r, my radius is 4, all over 360. So I multiply my numbers together first. I get 1,744. I multiply that times pi, and then I divide it by 360. If I round to the nearest hundredth, I get 15.22, and I'm talking about centimeters. Next one. This one looks like it's just the opposite. I'm giving you this whole angle right here, except I want to know what this small angle is here because I'm looking at the arc length of this piece. So to figure out this small piece right here, I'm going to do 360 minus 288, and I get that this is 72 degrees on the inside. And now that I have it, I can plug it into my equation. So 72 degrees times 2 pi, my radius is 9.5, all over 360. So I multiply all my numbers together first. I get 1,368 times pi, all over 360. And then I just put that into my calculator. If I round to the nearest hundredth, I get that the arc length is 1. Oops, I think I did something wrong there. 368 times pi over 360. There we go. I get 11.94, and I'm talking about feet, so my answer is in feet. Okay, so just being really careful that you're looking at the correct arc length. Number 5. If EB is equal to 15 centimeters, so here's EB, this is 15. Okay, that looks like a radius right there. Find the length of CD. I want to know what this arc length is right here. Okay, well, it looks like I'm given this angle right here is 68 degrees, but I want to know this angle over here that matches up with this arc. Now, I see that this right here is a diameter. BD is a diameter. Because of that, I know that this whole thing should be 180 degrees. So to figure out what's left over in the green, I'm going to take 180 and I'm going to subtract 68 from it. When I do that, I get 112. So this angle right here is 112 degrees. Now that I know that, I can put it into the equation. So the equation is my arc, my angle, 112 degrees, times 2 pi r, my radius is 15, all over 360. And now it's just a regular problem that I'm going to use my calculator for, so I'm going to multiply all the numbers together first. I get 3,360 pi over 360. I multiply 3,360 times pi. I divide that by 360. My answer, the length of arc CD is approximately equal to 29.32, and I'm talking about centimeters, so my answer is centimeters. Number 6. If NR equals 8 feet, find the length of NMP. NMP. I want to know that whole section there. Well, I already know that this piece right here is 162. I can figure out what this small piece is right here by taking 180 and subtracting 162 from it. And if I do that, I get that this little piece right here is 18 degrees, which means that this little piece over here that's a vertical angle is also 18 degrees. If I were to add all 3 of those together, I'm going to get the full angle measure of all 3 of those. So if I do that, I get 198 degrees. I'm going to use that 198 in my equation. So length equals 198 times 2 pi r. My radius is 8 nr, yep. And then I put that over 360. Okay, multiply my numbers together first. On top, I get 3,168 pi over 360. When I multiply this times pi and then divide that by 360, I get approximately 27.65, and I'm talking about feet, so my answer is in feet. All right, on to the next. Okay, we're skipping through a couple of them, as you can kind of see here. No biggie. All right, number 7. If VS equals 12 meters, find the length of UT. Okay, so VS, this whole thing is 12. I want to find the length of U to T. I want to know just this one piece right here. Okay, now I know I'm going to have to figure out what this little angle is right here first. I know that VS is a straight line. I also know that if you were to look, this angle right here is 127. Its vertical angle is right here. These are both 127. I know that there's a 90-degree angle right here. 90 degrees of the 127s are already being used, so to figure out what this small green piece is over here, I'm going to take 127 and I'm going to subtract 90 from it. Because if I do that, I'm going to get what's left over, this small green piece. And this small green piece is 37 degrees. Okay. Now, this time, I'm going to use the same equation, but notice that VS is a diameter. And so if it's a diameter, I need to make sure I use that in my equation. So when I go to find the length, I'm going to do my angle measure, 37 degrees, times, and now I'm not going to do 2 pi r, I'm just going to do pi times diameter. Pi times my diameter is 12. I'm going to divide that by 360. Okay. So I multiply the numbers on the top first. 37 times 12 gives me 444 pi over 360. I multiply times pi, divide by 360. I get that my length of UT is approximately 3.87. We're talking about meters, so my answer is in meters because we're talking about length. And with length, you've some kind of distance. Okay, slide on down to number 9. If FG equals 27 yards, find the length of arc FED. Okay, so FG is this piece right here. That is a radius. Okay, so I know to use the radius when I'm going to do my equations here. I want to know the length of FED. F through E all the way to D. Okay. First thing I have to do is figure out what the angle is. That's this section here that matches it. Now, you can do it a couple different ways, but what I'm going to do is I'm going to take the whole circle 360, and I'm going to subtract these two angles from the 360, because that's going to tell me what's left over. Okay, so you can kind of see how we're using some old stuff here to help us out. So that's 127, so if I subtract 360 minus 127, I get 233 degrees. So this angle is 233 degrees. So now I can plug it into my equation. Length equals 233 degrees times, I've got a radius, so it's 2 pi r, my radius is 27, all over 360. All right, I multiply all the numbers on the top together first. I get 12,582 pi over 360. I multiply these two together, and then I divide it by 360. I get approximately, so let's do that one, 2,582 times pi divided by 360. I get approximately 109.79 would round up to be 80. And we're talking about yards, so my answer is in yards. All right, last one for this part. A 16-inch pendulum swings through an angle of 40 degrees. How far does the tip of the pendulum travel in a single swing? So it tells me what my degree measure is, and it also tells me that my pendulum is 16 inches. So imagine I've got something up here, right? And it's swinging. Here's the pendulum. So it swings from here to here. All right, so here it is swinging. Here's the motion of it swinging. So it goes swing to swing to swing to swing, back and forth and back and forth. Now imagine this is a whole circle. This would only be considered a radius. So this 16 inches is a radius. So all I really have to do is plug and chug into the equation. I already know the degree measure. It's 40 degrees times 2 pi r. My radius is 16. All over 360. I multiply the numbers on top first. I get 1,280 pi over 360. I multiply 1,280 times pi. I divide it by 360, and I get approximately 11.17, and we're talking about inches. So my answer is in inches. Okay. Now, that was the first part of our homework here, or of our notes, arc length. The next part we're going to talk about is called area of a sector. Don't worry, there's not that many examples. We're going to breeze through it quickly. Okay. A sector of a circle is a section bounded by a central angle and its intercepted arc. So think of a sector like a slice of pizza. Okay? Sector area means if this whole thing was a pizza and the section that I want to eat is this area on the inside, that slice of pizza, that's a sector area. You can think about arc length that we just did as like the length of the crust around the pizza. So the arc length is the crust on the pizza, right? How much pizza length do you have? And then the sector area is the actual slice of the pizza that you want to know how much can I eat. Now, to find the area of a sector formula, it's very, very similar to the other one. It looks like this. The area of a sector equals, X is still going to be my degree, whatever my degree is, except this time I'm going to multiply by pi r squared. That's the radius squared times pi. That's how you find the area of a circle, and we're talking about area of a sector, so it makes sense. And then I'm dividing it by 360 because in a circle I have 360 degrees. So let's see how easy this is. We're going to find the area of each shaded sector, and we're going to round to the nearest hundredth. Okay, so my area is equal to, so I'm trying to find this slice of pizza right here. The area of this angle right here, so is 51 degrees, times pi r squared. My radius is 16. So I'm going to take that 16 and I'm going to square it. And I'm going to put that all over 360. Okay, so the first thing, order of operations, is I have to square my 16 squared. Right, that's 16 times 16. This number right here is really 256. So I have to multiply 51 times 256. I get a huge number, 13,000, 56 pi over 360. So now I just take that number, I multiply it times pi, and I divide it by 360, and rounding it to the nearest hundredth, my area, go like this so you can see, my area is equal to, so 10th hundredth, so instead of 93, the number after the 3 is a 5, so I'm going to round it up to be 94. So it's 113.94. Now, when we talked about length before, if we were just talking about length, we would be saying feet. But since we're talking about the area of something, it is feet squared. All right, next one. PQ is equal to 22 centimeters. Okay, that's the radius. I already have my angle given to me, so this should be an easy problem. We're just plugging it into the equation. So my area equals, my degree measure goes first, 139, times pi r squared. My radius is 22, so 22 squared, over 360. Just like the last one, first thing I'm going to do is I'm going to square my 22. So I really have 139 times pi times 484. I now take that 484, I multiply it times 139. I get a very big number. I take that really big number, I multiply it times pi, and then I divide it by 360. So I get, my final answer is that the area is equal to 587.09. I'm talking about centimeters, and they are squared because it's an area. Sorry, I went off the page a little bit there. All right, just a few more. Number 4. I am given that GH is 13 yards. That's still a radius. Now, notice, this time I told you that this area over here, this angle is 126, but I want to know what this angle over here is. That's shaded. So, to figure out this angle, I'm going to take the whole circle, 360, and I'm going to subtract 126 from it, and that's going to tell me what is left over. So if I do that, I get 234 degrees. So this angle right here, this major arc, is 234 degrees. And now that I have that, I can plug it into my equation. Area equals my degree measure, 234, times pi r squared, my radius is 13, all over 360. Okay, first thing I'm going to do is I'm going to square my 13, and I get 169. I'm now going to multiply 169 times 234. I get a huge, huge number, 39546 pi. And then I'm going to divide. I'm going to multiply this first by pi, and then I'm going to divide by 360. So I get that my area is equal to 345.10, and then it's yards, and because it is area, it's squared. So it's really not like a hard thing to understand or a hard thing to do, but it is just a lot of like plugging into your calculator and making sure you get the right thing. It's also making really sure that you are looking at what's given to you and you're only trying to find the shaded area, not the unshaded area. All right, just a couple more. I actually think, yeah, we got about 5 more, so close. All right, YZ equals 9 inches. So this part right here, this is 9 inches. I know this little section is 42, but I want to know the shaded area out here. So I'm going to take 360 and I'm going to subtract 42 from it, and that's going to tell me what my area is, or my angle is, and that is 318 degrees. All right, so my area equals, my angle is 318 times pi r squared, my radius is 9, over 360. I'm going to save like a little bit of space here. I already know 9 squared is 81. So I'm going to multiply 81 times 318. I get 25,758 pi over 360. And now you know what to do. You just multiply times pi, divide by 360. If you don't have a pi button, you can use 3.14. That's also okay. So my area is equal to 224.78, and we're talking about inches squared since it's area. All right, let's flip to the next page. All right, next one, number 8. Okay, so I know that MN is 29.5. That's a radius. Great. I do not know this shaded angle right here, but what I do know is that this angle right here is 90. So to figure out the green angle there, the larger one, I'm going to take 360. I'm going to subtract 90. When I do that, I get 270 degrees. Now I have all my information. Just plug it into the equation. Area equals 270 degrees times pi r squared. My radius is 29.5 all over 360. Okay, so I can kind of show you how I put this in my calculator in case you are wondering. I'm going to do 29.5 squared first. So you can either use the button, the squared button, or just multiply times itself. I get 870.25 here for this. I'm now going to multiply that times 270. So I get a crazy big number. And I take that number and I divide it by 360. So I get my area is 652 point. So it's 68. The number after is a 7, so it becomes 69. And then we're talking about miles squared. Okay. Now, for the last 3 problems over here, we're going to find the total area of the shaded region, and then we're going to round to the nearest hundredth. What you're going to notice here for these problems, and I'm going to scooch us back. I'm sitting on the floor right now, and there's sun coming in, and it's That's what I was afraid was going to happen. Okay. There's just sunshine coming in, and I don't want this sunshine to ruin my picture. So we're moving back. Okay. So for these problems, we're going to notice is that there's more than one shaded area. So we're going to find the shaded area of one spot, the shaded area of the second spot, and then we're going to add those 2 areas together. Okay, so let's start. For this first one here, all right, excuse me, number 11, I see I've got 2 angles that are shaded, and they just so happen to be vertical angles. So if this one down here is 46, guess what? This one over here is also 46 degrees. So what I can do is I have got 2 choices. I can do the 46 degrees one first by itself, and then I can take that and add it to itself a second time, right? Because they're both going to be the same. Or you can just add together 46 and 46, right? Your 2 angles in total. And you'll get 92 degrees, and you can just use 92 degrees for your equation. So it really doesn't matter how you choose to do it. They're both going to get you the same answer. I'm going to do it this way just because it's like one less step for me. All right, so my area is equal to 92 degrees times pi r squared. My radius, let's see, hg is 7. That is a radius. So it's 7 squared, and I'm going to divide it by 360. Well, I know that 7 squared is 7 times 7, which is 49. So I'm going to do 49 times 92. I get 4,508 pi over 360. So I multiplied times pi, divide by 360. So the total area is 39.34, and I'm talking about centimeters, and because it's area, it's squared. That's it. Easy stuff, man. Okay. Number 12. XY is 30 feet. Okay, so be careful. XY is not a radius, it's a diameter. The radius would be half of it. So my radius is half of 30, or 30 divided by 2, so it's really 15 feet. That's important to know. I give you the shaded area angle is 113. These are vertical angles, so this one is also 113 degrees. If I add together 113 and 113, in total, I'm going to get 226 degrees, and I'm going to use that in my equation now. So I've got my area is equal to 226 degrees times pi r squared. My r squared is 15 squared. Be really careful. And then I'm going to divide that by 360. So the first thing I'm going to do is do 15 squared. This gets me to 225. I take 225 and I multiply times 226. I get 50850 pi over 360. So I multiply it times pi, divide it by 360. My area is equal. Notice I always put the A, right? Or on the other problems, I put the L for length. I always put what I'm trying to solve. My area is equal to 443 point, it's 749, so I'm going to change it to 75 feet squared. All right. We're so close. 2 more. Number 13. Okay. I tell you, first of all, that EB is 10.4. So E to B is 10.4. That is a radius. That's good. So I don't have to do anything there. Now the problem though is I tell you this piece is 143 degrees, but I want to know what this piece is. Now I do notice that DB is a diameter. A diameter means it's 180 degrees. So to figure out this angle right here, I'm going to do 180 and I'm going to subtract 143 from it. And that's going to give me my one angle that's there. 143. So this small angle is 37 degrees. These are vertical angles, so this one is also 37 degrees. In total, I have 37 plus another 37. So in total, I have 74 degrees. So I'm going to use 74 in my equation. So area equals 74 degrees, right? That's the two 37s put together, times pi r squared. My radius is 10.4. I'm going to square it, and I'm going to divide it by 360. Notice I write out everything every single time. You literally have to. If you don't, you're not going to get it right. Okay, so the first thing I'm going to do is I'm just going to square this one first. If I do that, I get 108.16. I then multiply that times 74. And so on top, I get 8,003.84 pi over 360. So I multiply this times pi. Ooh. And then I divide by 360. I get that the area is equal to 69 point. So I've got 846. So I'm going to make it 85. I'm talking about inches, and because it's area, it's squared. All right, last problem I shall do with you this year. That's a new problem. Oh my gosh, so sad. Okay. Looks the hardest, probably not. First thing I give you, JM is 10 millimeters. Here's JM. That looks like a diameter. So to find a radius, I'm going to take half of 10, or 10 divided by 2. That gives me 5 millimeters. Great. Now, I have to figure out the angles that are shaded. Now, I already know that this is 58 degrees. And guess what? I actually know what this angle is right here because this is a diameter. And since this is a diameter, this has to be half of a circle, or it makes a straight line, so it's 180 degrees. So to get my total area of the angles there, I'm going to add together 180 plus 58, and I get 238. So I'm going to use 238 as my degrees, and then I'm going to plug everything else in. So 238 times pi r squared. Now be careful, you know your radius is 5. Divided by 360. Okay, first thing I'm going to do, I know that 5 squared is really 25. Okay. So I'm gonna zoom out just a little here, go like this. All right, so I've got 25 times 238 is 5950 pi over 360. Okay, so I take that number, I multiply times pi, and then I divide it by 360. So my final answer is that the area is equal to 51.92, and it's millimeters, and it's squared because it is area. All right, guys, so that was our final problem there for new material. You can now go back to the actual 10.6 notes and homework on Edmodo. You can finish up your final homework here for me, arc length and sector area. Next week on Monday, I'm going to give you guys a study guide to complete. You'll have one more Wellness Wednesday next week, our final one, and then you will have your final quiz over these last 3 sections. I believe is 10.4 to 10.6. You'll have that last quiz on Thursday and Friday of next week, and then we are finished with this class. The week after that is only going to be makeup activities if you choose to do them. You will still have to get online every day just to check in for attendance with me, but other than that, we are now finished with new material. We're done. You should be so excited. I'm excited. Okay, so if I don't get a chance to chat with you, have a great weekend. Miss you all. Wish we could have been together for this. And have a great day. Bye. I don't know if you could see that, but bye. Love you all.